So I'm going to start with the first key concept of drivers. So drivers for PlaceOS can be two things. It can be an integration, so something that is managing communication between PlaceOS and a third-party API or device, so a communication driver. And then it can be something that coordinates multiple drivers or integrations, and that is essentially a logic driver. So we have these two concepts within drivers, integration and logic. So those two things work together to provide a solution. So an integration driver might be Linnell access control, and the logic determines when to open the door. So one manages the communication, one manages the behavior and what happens, and it will need more context. So the logic needs to know, well, who's there, so it needs another thing to integrate with. It needs more context around when to trigger that open the door action. So it will be coordinating between the Linnell driver and the identification system and maybe some sort of tracking method so it knows who and where someone is to then trigger that action automatically. So integration and logic go hand in hand, and that concept is throughout PlaceOS. But in terms of drivers, we have the two different types of drivers, and then they can be treated in the same way. So they're both just as modular. So the next concept is what I really touched on already there, modules. So the difference between drivers and modules is that a module represents a specific instance of the integration and the logic, meaning it can have, it can inherit default settings, and then you can change those settings for that specific instance of that integration or logic. And when it's an integration driver, the easiest way to think of a module is a digital twin of that specific thing, that device, that third-party integration. We now have a digital representation of it within PlaceOS. So if that's a TV, the module that we have in PlaceOS equals the digital twin of that TV, because there's two things about a module. We get state and we can change behavior, and well, there's three things really, and we can have settings wrapped around this. So the state gives us the live state when it's a module, so the real-time state of that device. Is it on? What's its current readouts? The ability to change behavior allows us to change the state, and then settings can define other things and parameters around that, which will then be editable within our admin interface back office. So driver is managing the communication and logic. When it's applied, it is a module. So a module is a specific instance or an applied instance of a driver. So the next concept is a system. So a system's where it all starts to come together. So we need somewhere to apply that module, right? So we have the driver that exists, that's been created, that lives in our repositories. To apply it as a module, we have to put it into a system. So a system sometimes, not always, can represent a physical space, or really it's just a collection of modules that you want to turn into a solution. So if you have these 5 modules and you want to have automation between each of them, and logic that takes care of that automation, you put it in the one system. So I'll use like a physical space as an example, just to make it clear. Let's talk about a meeting room. So in a meeting room, we need integration drivers to control the elements of the meeting room. So the audio visual, the TV, the sound, the video conferencing, and then some of the environmentals, the air conditioning and the lighting. So each of those will be an applied driver, i.e. a module, for the TV, for the air conditioning. Some of those will be very specific to what's in that room. There could be modules that are shared across multiple systems. So something like the lighting and the air conditioning is usually at least floor-wide or sometimes building-wide, and we can share that integration across multiple systems. So modules can live in two systems or more at the same time. And just think about that context, why you need that, because sometimes if you're creating a system, there'll be modules that are shared that are not only specific to that physical space or that system. So the meeting room example, that's the lighting and the air conditioning. But then all the specific things will have its specific IP addresses and live probably only in that system. So the TV, as an example. And then we need some logic. What do we want this system to do? Are we just monitoring things? So the logic is just for some sort of analytics of how many people walk into the room. So we're just connecting to the devices to get their state. We're not sending any changes to the behavior of those devices. And then we're reporting back to a dashboard. Well, then in that case, the logic module will be something around analytics of the usage of that room. Or are we using that room for audiovisual control, so meeting room control? There will be a logic module that will be specific for meeting room control. And then within a system, you can change settings within that system. So you can deviate from the defaults that come with the module and redefine the parameters or specific details. And that is all just within our back office tooling. It inherits all of these different settings, allows you to edit those. And one of the main places it's inheriting this is from the next concept of the zones. So zones are a collection of systems. And the hierarchy is that if you create a zone and have zone settings, all of your systems will inherit those settings. So this is where you can make changes to a global level, or you could have smaller zones. So a common way of managing zones might be, and again, we'll use physical space, but it doesn't have to be physical space. We might have a zone for the organization. So PwC is the organization, will have a zone PwC. Then they'll have a zone for the region, PwC Asia Pac. Then they'll have a zone for the city, PwC Singapore. Then they'll have a zone for the building, Marina One. Then they'll have a zone for the floor, and then they might have zones for different system types. So a lobby versus a meeting room. So then you manage your systems, you assign them to the right zone, and they automatically inherit the right settings. And then you can change settings at the appropriate level. Zones have systems, systems have modules, modules come from drivers. And those are the concepts we just went through. So the final concept to discuss is the interface. And you'll know from our many other videos that user experience, user interface is not the same thing. What we really get at there, what we mean is that you don't need visual elements, you don't need buttons on either physical buttons or buttons in an app or on a touch panel. That's not the way to think of interface. Interface means how the user interacts, and it may not be that traditional method. And the interaction might be as simple as turning up. So walking into a room, if we know who that person is, we can trigger things automatically. And now that you understand our concepts, you can probably sort of start to work out how and when you can do that. So if we have an integration driver that gives us location data, and we have a logic driver that wraps that around with the logic across other integrations, we can then open doors automatically, turn things on automatically. So if we track the person through Cisco Meraki and Cisco WebEx cameras when they arrive in the room, that's giving us location information. We also then need to know what MAC address belongs to what employee. So then we have an integration into internal corporate systems. And then we need to have some logic around that. So when it sees an employee, it looks up their privileges, checks if they have the right privilege, and opens the door, turns on the video conferencing system. So you need the right combination of integration and logic drivers, and we can achieve the user outcome, the user experience. Now, user interfaces still have a time and a place. So there are apps and touch panels and integration into Slack and other things. When it's literally a front-end interface, then we're just leveraging a JavaScript API. So the front end and the back end are decoupled, and that means the integration's happening in the platform, not the front end. So the front end doesn't have any smarts. That's just a visual representation, and that's just making calls back to PlaceOS, which is talking to the devices and coordinating things with the logic without the front end. The only logic that sits on the front end is related to the interface and how it behaves. And that means any interface developer can develop the interface on their own without having to have the domain knowledge of integration, IoT or smart buildings. They can just build these interfaces in their own tools, native apps, web applications, anything else they can think of, the physical buttons, and that all comes back to the platform via JavaScript APIs.